Dimensional analysis ensures your answers make sense with the correct units and your calculations are correct through your conversions. In chemistry, you'll be expected to apply dimensional analysis to more challenging multi-step problems. In this video, we're going to level up your dimensional analysis skills. If you've already mastered basic unit conversions, it's time to work through longer, more advanced conversion problems. To solve these problems, we are first going to list all conversion factors given, and then piece together a unit map based on what conversion factors we have and what units are connected. We can then set up all units to cancel based on what the starting or given value is. Write the given value over 1. It forces a clean setup and makes cancellations effortless. For this problem, we have a spacecraft uses 0.45 kilograms of fuel per second. If the spacecraft travels to Mars, which is on average 225 million kilometers away, and travels at 25,000 kilometers per hour, how many tons of fuel will it use on the entire trip? In the problem, we are given 0.45 kilograms per second, 25,000 kilometers per hour, 1 ton per 2,000 pounds, 1 kilogram per 2.20462 pounds, in 1 hour per 3,600 seconds. The given or starting value is 225 million kilometers, which can be written as 225 times 10 to the 6th kilometers, or 2.25 times 10 to the 8th kilometers, moving the decimal to the correct place for scientific notation. Based on the conversion factors that we have, kilometers and hours are connected by the factor 25,000 kilometers per 1 hour. So from kilometers, I can next convert to hours. Hours are also connected to seconds in 3,600 seconds per hour, so I can next convert to seconds. Seconds are connected to kilograms in the conversion 0.45 kilograms per second, so I can next convert to kilograms. Kilograms are also connected to pounds in the conversion 1 kilogram per 2.20462 pounds, so I can next convert to pounds. Pounds are also connected to tons in the conversion 1 ton per 2,000 pounds, so I can convert to tons. The end unit we need is tons, so we have completed our unit map and can now set up all units to cancel. Starting with the given value of 2.25 times 10 to the 8th kilometers, I will write 2.25 times 10 to the 8th kilometers over 1. In the next fraction, I will put 25,000 kilometers on the bottom and 1 hour on top. In the next fraction, I will put 1 hour on the bottom and 3,600 seconds on the top. In the next fraction, I will put 1 second on the bottom and 0.45 kilograms on the top. In the next fraction, I will put 1 kilogram on the bottom and 2.20462 pounds on the top. In the last fraction, I will put 2,000 pounds on the bottom and 1 ton on the top. We will make sure that all units cancel out, so kilometers cancel out, hours cancel out, seconds cancel out, kilograms cancel out, and pounds cancel out, leaving us with tons as our final unit. Multiplying and dividing all values, we get 1.61 times 10 to the 4th tons. Keep intermediate numbers unrounded, and round once only at the end. In this problem, we have a mine is flooded and is being drained by a pump rated at 500 gallons per minute. How many cubic meters of water will it remove in 24 hours? First, let's list out all the conversion factors that we have. We are given 500 gallons per minute, 1 gallon per 3.78541 liters, and 1 cubic meter per 1,000 liters. For our time conversion, we also know that there are 60 minutes for every 1 hour. The given or starting value is 24 hours. Based on the conversion factors that we have, we're going to see what units are connected to each other. Hours are connected to minutes in the conversion 60 minutes per 1 hour, so from hours I can next convert to minutes. Minutes are connected to gallons in the pump rate of 500 gallons per 1 minute, so I can next convert to gallons. Gallons are connected to liters in the conversion 1 gallon per 3.78541 liters, so I next can convert to liters. Liters are connected to cubic meters in the conversion 1,000 liters per 1 cubic meter, so I can next convert to cubic meters. The end unit we need is cubic meters, so we have completed our unit map and can now set up all units to cancel. Starting with the given value of 24 hours, I will write 24 hours over 1. In the next fraction, I will put 1 hour on the bottom and 60 minutes on top. In the next fraction, I will put 1 minute on the bottom and 500 gallons on top. In the next fraction, I will put 1 gallon on the bottom and 3.78541 liters on the top. In the last fraction, I will put 1,000 liters on the bottom and 1 cubic meter on top. We will make sure that all units cancel out, so hours cancel out, minutes cancel out, gallons cancel out, and liters cancel out, leaving us with cubic meters as our final unit. Multiplying and dividing all values, we get 2.73 times 10 to the third cubic meters. Your turn to pause and try out solving the question. A research pump moves 2.6 liters per minute continuously for 18 hours. Convert the total to cubic centimeters. List your conversion factors, build your unit map, set up your fraction so units cancel, and drop your final answer and your setup in the comments. A patient is ordered to receive 1,000 milliliters of normal saline over 8 hours. The IV tubing set delivers 15 drops per milliliter. How many drops per minute should the nurse set the IV to infuse at the prescribed rate? In this problem, we are given 1,000 milliliters over 8 hours and a drip factor of 15 drops per 1 milliliter. We also know that 1 hour is connected to 60 minutes, and we need to convert milliliters per hour to GTT per minute. Based on the conversion factors that we have, milliliters are connected to GTT or drops with the conversion 15 GTT per 1 milliliter. And hours are connected to minutes in the conversion 60 minutes per 1 hour. Starting with the given value of 1,000 milliliters per 8 hours, I will write 1,000 milliliters over 8 hours. In the next fraction, I will put 1 milliliter on the bottom and 15 GTT on the top. In the next fraction, I will put 1 hour on the top and 60 minutes on the bottom. We will make sure that all units cancel out, so hours cancel out and milliliters cancel out, leaving us with GTT per minute. Multiplying and dividing all values, we get approximately 31.25 GTT per minute. A physician orders Ceftriaxone 75 milligrams per kilogram per day to be administered in 2 divided doses for a pediatric patient. The child weighs 18 kilograms. How many milligrams should the nurse administer per dose? In this problem, we are given 75 milligrams per 1 kilogram per day, 1 day per 2 doses, and the child's weight as 18 kilograms. The given or starting value is 18 kilograms. Based on the conversion factors that we have, kilograms are connected to milligrams in the conversion 75 milligrams per 1 kilogram per day. So from kilograms, I can next convert to milligrams per day. Milligrams per day are connected to milligrams per dose with the conversion 2 doses per 1 day. The end unit we need is milligrams per dose. So we have completed our unit map and can now set up all units to cancel. Starting with the given value of 18 kilograms over 1, I will put 1 kilogram in 1 day on the bottom and 75 milligrams on the top. In the next fraction, I will put 1 day on the top and 2 doses on the bottom. We will make sure that all units cancel out, so kilograms cancel out and days cancel out, leaving us with milligrams per dose. Multiplying and dividing all values, we get 675 milligrams per dose.